Hey and welcome to my channel where we talk about bikes and more. Today I'm going to be explaining the meaning of torque and power. What it means, what are the performance implications between them. And the reason why I want to talk about this, firstly, it's because it was something that I actually misunderstood for a long time, I didn't really look into it, but I just didn't really understand it until when I started riding motorcycles, and because engines are so different, I really got to understand the meaning between what is power and what is torque, and what it does, and what's the performance implications. And the second reason I want to talk about it is because there seems to be a lot of misinformation out there about what it means, and there's a lot of people who don't understand it. And like one example is, a lot of people say a high torque engine will give you good acceleration on the get-go, but a high power engine will give you good top speed. Now that is seemingly right. There's a lot of examples where you can say yes, that's right, but it's actually false. It's just false information. So that's why I really want to explain today what it means, what's torque mean, what does power mean, and I didn't really want to do this. Video, but I kind of just wanted to get it off my chest, because I finally understood it, and I can say it in a way that others can understand. We'll just get warmed up to it first, and I'll just give you a quick definition. So, power is a function of torque and RPM. So when you put torque and RPM together, and there's a constant there, which I don't really care about, because I just want to explain on a conceptual level. So I won't be getting into too much numbers and stuff. I just want to explain, relative and the concept of it. So it's a function of torque at a given RPM, and that's what the output is power. So we'll get warmed up to it, and I'll draw a little graph here. So down on the vertical axis, we'll have the torque, and on the horizontal axis, we'll have the RPM. And we'll talk about two different bikes. So one is a high torque but low horsepower bike. So maybe this bike's got 75 foot-pounds of torque maximum, with 60 horsepower, let's say. And we'll talk about another bike in red, which is low torque but high power. So maybe this is like an inline 4 600cc, and let's say it's got 45 foot-pound maximum, but it's got 140 horsepower, 130, 140 horsepower. So it's got a lot more horsepower than the bike with a lot of torque, which we said has only got 60 horsepower. So we'll start by plotting the high torque bike. So we start at low RPM, and we plot, and it's got it red lines at, we'll say, about 7,000 RPM, and at the red line, the torque really drops off. So the torque is pretty great. Like, the torque is pretty constant, but at the end, at the rev limiter, that's when it really drops off, and actually, if you keep going past that, you can damage your engine. So it's got this much torque, and it stops at this RPM here. 7,000. Now we plot our low torque but high horsepower bike, and this bike, the torque line is low, but it keeps extending and it keeps going all the way out, way past 7,000, up to almost double, even past double. So now we'll plot the power. So power is a function of torque and RPM, and I'm not going to give exact figures, but I'm going to give rough figures. And this is sort of what you'll see when you do a dyno. So we start with our high torque bike, and you'll see that as I plot it, because of the torque's pretty good, and RPMs are rising, so the horsepower is rising, it's going up. And what you actually notice is the horsepower keeps going up even when it passes the peak torque, and the reason for that is because the proportion of the torque dropping off is less than the proportion of how the RPMs are rising. So remember, horsepower is torque and RPM. So the torque is dropping off, but the RPM is still sort of rising. So that's why typically on most cars and bikes, the peak power is a few thousand RPM higher than the peak torque. And then we start plotting our high powered bike. So it's got low torque. So it starts off with low power. At the RPM range, it's less of the high torque bike. It's less power because it just doesn't have that torque as part of the formula. But it's not until later on, and it's this is what makes bikes powerful, is it's able to hold its torque, maintain a good torque at a higher RPM. And so, power is amount of work in a given time. So we'll say the work is, the torque, and the amount of within a certain time that it's applying that torque, the RPMs, is doing a lot more work. So the low torque bike is doing work, but it's doing it at a slow rate. And that's why it's not powerful. The powerful bike, even though the torque is little, but it's the RPM. It's doing it at a very, very fast rate, and that's what makes it powerful. So that's just a little, getting warmed up to it. Now I want to talk about the performance implications. So what does it mean, and what does it feel like, and which one's better? Which one's faster? So if we start with, say, the wheel of our high torque, low power bike. So we've got a wheel, we've got a little swing arm here, and we've got the engine, which is producing 75 foot-pounds. And what actually gives bike a performance, or a car, is it goes through the gear and it produces a torque on the wheel, and then there's the distance from the axle to the ground, and then that will convert the torque into a force, because the wheel is sort of like a lever, the torque on a lever, and it's this force here that actually you can know how fast a bike will go, how fast to accelerate, and what its top speed is. And so we draw our other bike, our powerful bike. So assuming this is an assumption, right? Both of these bikes have the exact same gear ratios, and the wheel size is the same. So the gearing and the wheel size is exactly the same. So we see our powerful bike, it's got less torque, which means it's got less force pushing the wheel. So we'll see what that means. And so we can draw another graph. And this is on the vertical we'll have the force, and on the horizontal we'll have say speed in kilometers per hour. And remember, this example, the gearing is the same. So at this stage we're not changing gears, we're just starting off. It's the same gear for both bikes, and you'll see them go. And so what you see is up to about 60 or 70 kilometers an hour when the high torque bike revs out. Let's say it's 60 usually. So there's a lot of force on the wheel, so it's going to have a lot of acceleration, but its top speed will be 60. But when we look at the powerful bike, it will rev out. It'll rev out to maybe 120 kilometers an hour, but the force is less. So it's got less acceleration, but it's got a better top speed. So I think that's where a lot of people get this idea of, torque, better acceleration, and power, higher speed. But where it actually doesn't make sense is I can change the gearing on the high power bike, and I can change it so it matches the top speed of the high torque bike. And now you can see the torque has multiplied significantly. So people talk about all these torquey characteristics. Well, now my powerful bike with little torque has got double or triple the amount of torque of my torquey bike. And so what's to say about that? Where's the torque then for the torquey bike? So and that's why I want to make the point. It's power. Power is everything. And if you go vice versa, you can up the gearing of the torque bike, and so it can get up to 120 like the powerful bike. But you'll see that the force is reduced by a lot. So where's your torquey characteristics then when you look at the output force and acceleration that it has, because it's made to go a higher speed. And when you look at it in a real life scenario where you change gears, you can see that the first bike goes up to 60, and it's got a lot of force on it, more than the powerful bike. And then you got to go into the next gear. When you go into the next gear so you can get a higher speed, you've lost torque because you've geared up. And so you can see now it's not accelerating or going as fast as the powerful bike. The powerful bike is still in the first gear, force range. It might go up to about 90, and then you've got to gear up again to third gear, and then you've lost a fair bit more force. And so now the acceleration at the top speed is nothing. And the powerful bike is still using the first gear force, which is now much more than the low powered bike. And so that's why power is the performance specification. You can having power means it's got the legs to either accelerate harder or reach a top speed, or maybe a compromise in both. Reduce a little top speed but get more acceleration, and it will beat the torquey low power bike in both aspects. And torque it's not really a performance spec. It just sort of describes the characteristics of what the bike's going to sound like. It does nothing in terms of telling you how fast the bike is going to go, how hard it's going to accelerate. The thing that tells you that is power. And then you might say, torquey bikes are better because they don't have to rev as hard, so they don't have to work as hard. But that's not actually true. Have you ever noticed why a high torquey bike, when you rev it up to about 6,000-7,000 RPM, there's a lot of vibration, and it seems like the piston's going to pop out. But you take like a high powered bike, you rev it at more 7,000-8,000, it seems very relaxed, very smooth. Now, the reason for that is because there's a real physical reason behind that. If you look at how engines make high torque or high power, first thing you realize, it's got nothing to do with the materials or anything like that. Higher power bikes use better materials. That's got very little to do with it. What the issue is, or what the thing in play here, is the way that it's configured. And so the high torque, it's got like a high lever on the crank, and that's why it's got a high torque. And the high powered bike, it's got a short lever on the crank, and that gives a low torque but more power. So how does it get more power? Now, in physics, you don't get something for nothing. So the high torque bike, it's got a longer lever, but the piston has to travel further now. So the stroke would be, say, 85 millimeters. It's got to travel double that, 170 millimeters, just to do one revolution. Where the high powered bike, it's got a, say, a 40 millimeter stroke, or 42 typically, and it only has to travel 80. So it's got to travel less than half the distance in one revolution. So a revolution happens, let's say they're both going 3,000 RPM or 5,000 RPM. The high torque bike, the speed of the piston is a lot more. The amount of force on the piston, the amount of force pushing it down and up, and the maximum speed it gets to, is more than double than that of the powerful bike. So the powerful bike is relaxed. So I hope that gives you a good understanding of the difference between power and torque. But now that you understand it, I can show you what you can do with that information on deciding what type of bike you should get, and that is you can toss it out in the rubbish. I think the purpose of my video is to make you realize that if you understand what it actually is, you realize that it doesn't actually matter. People buy bikes not because of... You shouldn't buy a bike because of the performance. You should buy something that you like. Maybe you like the low revving sound of a torquey bike. Who cares about the performance? Maybe you like the throttle response. Maybe you like the throttle response of a high-powered bike. It's got a more fine-tuned throttle response compared to a torquey bike, which is more like an on-off switch. And most people can't even extract 50-60% out of a high-powered bike. You take a 130 horsepower bike, 200 horsepower bike. A lot of people are just driving around at quarter throttle, half throttle maximum. People can't extract bikes are just too fast. They're not like cars where whatever the power spec is, that's what the power you put down. There's a lot more to riding a bike than the performance spec, and that's why it's not important. What's important is, does it fit you? Are you comfortable with it? Are you comfortable with the performance, the way it accelerates, and does it do what you need? And that's what the most important thing about choosing a bike. So don't base it on power or torque or anything like that. Go and see what you like. Go see what characteristics makes you feel comfortable, and that's how you choose. So anyway, I hope you've received something from this video. That's all I've got for you today, so take it easy and ride safe.